Good day and very welcome to everybody for today's CNPS Saturday session, hosted by me, Ian Cowan. Now, today we have an interesting topic. It's a topic actually which we've dealt with in some detail in some other forums, to wit, special relativity. But we have a person who's been participating quite regularly in our various forums for some time now, Jerry Harvey. And, he's been making a number of interesting observations. And we've gone away from dealing specifically with special relativity in the last few weeks. So we had some discussions with Jerry and we persuaded him maybe to give a talk. Actually, he was going to give a talk, I think, on things like whether the speed of light is constant or not. But we decided that he has an inquiring mind. And I think, I haven't actually asked him this, but I am sure he will agree with me in supporting the comment of the French philosopher Jean de La Bruyere. His comment was, the exact contrary of what is generally believed is often the truth. Now, a lot of people, in the highways and byways won't accept that, but I, for one, do accept it, and I feel that Jerry probably would as well. So, what we'll do is I'll just read out actually the text we've given. It's fairly short. His critique is of this nature, that what within a theory is a valid description of reality and what is questionable or possibly inaccurate. So he's putting his own mind to this question, and it's a close examination of the main ideas of special relativity without the use of complex mathematics. And that's interesting as well, because we have had various talks looking at the derivation of the Lorentz transformations via the SRT postulates and other things about theory, Maxwell's equations, and I've looked at things and how that affects the speed of light and the properties of maybe a postulate ether and so on. So he's going to critique it from a sort of a fairly straightforward way without using complex mathematics and presumably partial differential equations and tensors and all that sort of thing. But he's going to analyze it for us. Now, as usual, I'll be keeping an eye on the comments coming in, so do excuse me if I'm distracted a little, and we'll deal with those specific ones which are addressed to Jerry, and then we'll open it up to the green room. I see some people in the green room are coming in, including a couple of people who are not regulars. I have spoken, so it's looking full. Yes, so that's about all. The only other thing is I'm inviting Jerry, because this was done to me when I first presented in 2013. They said, would you like to say a few words about yourself? You're a new person. Well, Jerry's not new, but he hasn't presented us before. So I invite Jerry to spend a minute or two just telling us a bit about his own experience and his own avenues in life and so on. So Jerry, I've brought you up now, and I'm going to, shall I bring your slides up, or would you like to say a few things without the slides first?
Oh, well, I could say a few words, I suppose.
Oh, okay. So I'm going to give you the floor, and then tell me when you want the slides brought up, and I'll bring them up. Okay? So the floor is yours, Jerry.
All right. Thank you. I'd say I'm an independent scientific researcher. Hold on, I'm sorry. Please forgive me. I should have had that turned off. I got into theoretical physics actually, sort of. I'd been into philosophy for quite some time, and I'd read, I'd gotten the hang of critical thinking, and so I happened to, I was at the mall and saw an Einstein shirt that looked really interesting. Had interesting, like design and everything, and a cool quote. So I bought the shirt, and I thought to myself, well, I can't go on wearing this shirt if I don't know anything about Einstein. I'd heard of relativity at that point, but I hadn't investigated it. So I bought a book on relativity, and I started reading it. And I was reading it with the intent to understand. I mean, I didn't just want to know how the theory goes, so to speak. Oh, we'll understand his theory. So that made me want to understand it all the more. So when I would read it, so I didn't understand so much of it. It didn't logically add up, and I kept thinking, well, he's a genius, you know. He I just kept giving him the benefit of the doubt that, you know, maybe he was on some other plane of intelligence that most people don't have access to or something. And well, I would just continue to read, and I kept finding mistakes, or just what I eventually started to think were mistakes. At first, I was just sort of trying to understand. Anyway, the more I would read, the more I started to question, and the more it became like a really big deal for me to keep investigating. And that I was 20, I think I was 21 then, maybe before. I'm 52 now, so I've been at this for 3 decades. Anyway, so I sort of got into, I was sort of into science, but I got into theoretical physics, and just like disproving Einstein was sort of my first experience, was trying to disprove Einstein. So anyway, there you go with my sort of spiel of my past. Anyway.
Well, thank you very
Ian,
much, Jerry. I
could
just,
I
if you
present
don't
the
mind me just
slides?
saying this,
If I can
because
figure
we're
this
going to
out.
put up your slides now when you request that. And we found that,
Okay.
well, I found anyway, and I mentioned this to Jerry, that the font was a little small in the default position. But we were able to get over that by asking all participants, because all participants have to do this themselves. In the bottom right-hand corner of the sort of black screen, there's a little square, broken square. If you click on that, you'll maximize it for your own screen, and you should be able to read the Jerry's slides perfectly there. So I'd ask everybody to do that for himself, because we can't do it for you. Okay. So shall I bring up the slides,
Sorry
Jerry,
about that. I
and
could have made it
bring
larger,
myself
but I
down,
didn't
and
think.
then I'll maximize the thing. Get rid of your photo,
Sure.
but I'll
Yeah,
keep you.
please. Thanks so much. All right. This is my critique of special relativity. You know, what is valid and what is possibly questionable or inaccurate. Uh, a close examination of the main ideas without much technical terminology and complex mathematics. This is my own personal understanding of the way the theory goes and its possible flaws or inaccuracies. So, see if I can get to the next slide. Yeah, the first postulate, it was Einstein borrowed from Galileo from 1632, the principle of relativity. It states that all inertial frames are equally valid. And that doesn't seem immediately understandable for a scientific, inexperienced person per se. I mean, the words have specific meanings that it seems that it's a difficult thing to sort of explain, even though once you understand it, it's quite simple to understand. Like an inertial, okay, there isn't a universal or absolute frame of reference, and all objects exist and travel relative to each other. That is sort of part of that. Galileo, one way to translate Galileo's thought is to picture a bus traveling down a smooth road at a constant velocity, and you can bounce a ball, and it'll bounce back up just as normal. You can walk around, you know, you don't lose your balance, just as if you were on the earth, on the ground outside. It's the same inertial effect. those are frames, like the frame of Earth and the frame of the traveling bus. I mean, if the bus were to accelerate or slow down, it would, the ball would go diagonally and you sort of lose your balance. So acceleration acceleration isn't a part of inertial frames. Like the the yeah, okay. Okay, the velocity of an object is determined through direct reference to another. I mean, there doesn't seem a meaning of a velocity without something to compare it with. So, I mean, if you were to picture an object in outer space, just with nothing around, just say it's even the only thing that exists. I mean, how to know if it's stationary or if it's in motion? I mean, there isn't any way to know unless unless another object is in the equation, such as, well, say it's a spaceship, and like you can't know how fast something goes either. If you were in a spaceship and you were traveling at a constant velocity, you wouldn't know if you were stationary or if you were traveling half the velocity of light or more, because it has the same inertial effect. And if there were another spaceship introduced that you could see, you could see, well, I'm traveling such and such velocity relative to this other spaceship, and you might even see the other person in the spaceship. Well, I mean, that's kind of out there, but say you're like traveling towards it, and the person might think, oh, that person's traveling right towards me, or you might think, well, that person's traveling right towards me. Like in both is theoretically just like either way is just as valid. It's just as valid to say that one's in motion or the other is, or any combination in between, like half and half, or 25% and 75%. Anyway, all inertial objects and frames exist as stationary or travel at a constant velocity. So that was what I was just explaining. There is no acceleration of inertial objects or frames, except through gravity, such as free fall, though that's sort of something I won't get into right now. If anyone is interested, I could share my thoughts later on, though. The Earth, however, isn't a truly inertial frame, since it spins and orbits the sun while the sun travels through the galaxy. So the Earth is gravity serves as a stabilizing groundwork. Like Earth is sometimes called a lab frame, where experiments are done, and they consider it an inertial frame, though it actually isn't. And I say it's inertial artificially, which isn't quite.
Jerry, we've lost your sound.
Oh, can you hear me?
I don't know if it's come back. Yeah, I can hear you now. Something happened there.
Oh, okay. Sorry about that.
Okay, we just lost it for a few seconds there.
Okay. Well, anyway, yeah. So gravity serves as, it sets the stage for objects to fall on land, and I have it written much more extensively and much more technical, but I'm sort of talking about. But I'll go to the next slide. The second postulate is the constancy of the velocity of light. And that means that the velocity of light is always 186,282 miles per second, regardless of how fast the light source and observer travel relative to each other. So that means that the observer and light source could exist stationarily from each other, without traveling away or towards, or the light source could travel really fast away, almost the velocity of light even, and it would still clock by the observer as the same standard rate. Somehow, uh, many suggest the constancy of the velocity of light was in Maxwell's equations, which I'm unsure. Some say that Einstein invented the idea himself, though I've looked into it, though I haven't found the answer. Uh, uh, there isn't adequate evidence for this theory. I think some cite the Michelson-Morley experiment, which had a null result, as evidence. However, though, there's different ways to see the Michelson-Morley experiment. I won't go into details about that either. Well, I guess I guess I could. I wouldn't know how much though. There's a lot to it. Anyway, the constant velocity of light, it doesn't seem understandable. Like, why is the velocity of light constant? I mean, it runs counter to Isaac Newton's famous equation of distance equals velocity times time. You get velocity in time, and you get the result. You get the distance. However, though, like when there's two stationary, like the light source and observer, whenever, like, consider that, and you get 186,282 miles per second. But then say there's one that's traveling away almost the velocity of light. There's all that unaccounted for distance that isn't taken into account. That the next slide is through time dilation. That time dilation is meant to account for the puzzling effect of the constancy of velocity of light. It's that time and space or distance would transform their abstract qualities to account for the to accommodate the constancy of velocity of light. That I wish I had my notes. I have a lot written down, but that I don't have available right now. Why isn't all time dilation mutual? Why don't time differences cancel each other out? Which determines which frame goes slower? This can be illustrated going to the spaceship example again, where if one spaceship travels half the velocity of light towards the vice versa, I mean, there isn't any way to determine which frame's time would slow down. It's a different story when you look at Earth and the clock on the planets doing it, such as the Hyperkeating, and because there's the stabilizing groundwork of gravity that on the sun. So, however, though, why isn't all time dilation mutual? Why is it the clock on the plane that slows down compared to the one on Earth? And that would mean the one on Earth goes faster. There's one frame that reaches the future faster than the other, which seems inconceivable. They don't even seem connected to the same reality. Factors that interfere with the workings of atomic clocks, such as, was 21. Almost ever since I was 21, I couldn't prove that time dilation was mistaken. Though I didn't believe it, though. The proposed evidence. Can you hear me? It keeps scrolling. Well,
Sorry to interrupt, Jerry, but we can hear you, but have been a number of comments coming in that it's very difficult, and I think it's mainly, as you told me earlier, your very old system, so it is breaking up a lot. But we'll continue, and maybe just keep the volume up and speak slowly. Thank you.
Okay, sorry about that. as it turns out, I had written quite a few years ago the idea that atomic clocks work on somewhat of a pendulum system, where that there's oscillations of the atoms of the cesium atoms, similar to what you had always heard that quartz watch that atomic clocks keep the most accurate time. However, though, it has been suggested that atmospheric pressure also could affect the workings, and possibly the ether or charge. I've heard from different people, and I'm unsure of that. However, though, with acceleration, the way that a pendulum works, such as you have a pendulum in a car, like say on the rear mirror, that and you're driving at a constant velocity, and you slam on the brakes, that immediately affects the oscillation of the pendulum. I mean, it knocks it out of its previously established. There's also an experiment where someone sets all these ticking metronomes on. If you can hear me, it's scrolling. Ticking metronomes on a platform, just a small platform with cylinders underneath, such as aluminum cans, to where it can oscillate side to side. So there are all these ticking. They're all ticking at different rates. Just click, 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 click. All these different metronomes, like a whole bunch of them. And after a short while, though, they level up very slowly. Eventually, they conform to each other and tick perfectly. That is caused by the slight rotation of the platform caused by the aluminum cans underneath. That those slight, they cause like a pendulum or a metronome that isn't quite there, but it is affected by the another action within the frame, such as a car slowing down. It affects the time the same way that an atomic clock might be affected in a plane when it accelerates. Okay, that's is there a maximum possible velocity? The idea that the idea that nothing may travel faster than the velocity of light is commonly accepted, of course. However, they don't provide a frame of reference to determine why they will. I guess it's maybe implied that Earth is sometimes the frame, such as with the clock on the plane experiment. Even though that's
Jerry, I'm sorry to come in again. I'm really making a mess of this. Sorry to interrupt. But the sound is really quite bad, and many people here can't hear it.
It keeps scrolling around.
Yeah, no, I'm just wondering, do you have many more slides? Are you halfway through, or have you only started?
Just one more.
Do you have many slides to go? You're on the third or fourth slide, I think. Because it's been suggested maybe that we reschedule this, but I'm not inclined to do that. I'm wondering, would you permit me, if you just had the slides up on the screen, if you permit me to read them, insofar as I can interpret them, and then during the conversation, we can maybe query you a little more. The sound is atrocious. I'm sorry. It's going on and off now. So
Yes, I
whatever
agree.
you want. I mean, if you insist on continuing, we will do that. It's up to you. But I'm just trying to make it easier. So, do you have many slides, Jerry?
Well, I don't know how well I have very few slides. This is the second to last one, actually. I
Okay.
had notes prepared to read, though I was sort of just going over each point. I have.
Okay. Well, let's continue. Let's continue. I mean, we can do this again at some later stage if people want later. But we let you finish. You don't need to absorb very much more time. I think you told me that you did a dress
I thought
rehearsal and it
that
only
I
took
could go
30
to.
minutes. So you might be able to finish
Well,
soon, and we'll have a discussion, and we'll ask
I'm
people in
so
the green
sorry.
room to give their interpretation of some of the issues that you've raised. So my apologies for my interruption. I'm going to disappear and leave
All
you
right.
totally in control again.
Oh well, my apologies for my old computer. Okay. Uh, yes. So if nothing may travel faster than the velocity of light, what is that velocity relative to? The Earth, the Sun, or any certain frame of reference, just in outer space? Or I mean, there isn't provided a frame of reference. So, um, of course, going back to the earlier point, like for any velocity to make sense, you need a direct you need a direct reference. However, though, there isn't any universal frame of reference to measure velocities by. So you you could take one frame of reference, and that's you could go half the velocity of light according to that. Or yeah, this is disastrous. I apologize so profusely. uh, the concept, which means is that it always you always get the velocity of light, like the 186,218 miles per second, regardless of how fast the light source or observer travel relative to each other. Uh, yeah. Uh, um, uh, I don't know. Uh, uh, Einstein had the thought experiment before. I think before he developed special relativity. What would happen if you catch up with light? What would happen if you reach the velocity of light? Like, and you can look at a light wave by you, traveling with it. How would it look? Would it look stationary? And if so, and if it were stationary, how would that look? He also had the idea that if you travel faster than the velocity of light, if you travel faster than a certain light beam, and you were to hold up a mirror, could you see your own reflection? Um, yeah, so if you were to travel faster than a light wave, if you were to travel faster, it couldn't possibly clock at 186,282 miles per second because you'd be going faster than it. It couldn't reach the detector or the I guess I'll go to the last slide. Again, I apologize to everyone for this. I feel really terrible. There's 2 more slides. I'm sorry. Hello? Okay. There's 2 more slides. What of Fitzgerald's length contraction and Lorenz's idea of mass increase? It was Fitzgerald who invented the idea of length contraction to account for why the Michelson and Morley experiment failed to detect the ether, or at least they thought so. That they could they couldn't detect it. So many exclaimed, "Well, the ether doesn't exist." Though the idea of the ether had been in the scientific community for quite some time, so many didn't want to see it go. So Fitzgerald invented the idea of length contraction to explain the interferometer, the device that Michelson and Morley set up to detect which way the Earth travels through the ether. Like if one side of the detector was shortened, if one side of the interferometer was shortened, he reasoned that it could, it could produce and the illusion of a null result. Like it's a result, but it looks as if there isn't a result. Fitzgerald had also he suggested that the ether pushes all objects to shorten in the direction of their motion. Uh, uh, that an invisible substance that permeates all existence. Um, yeah. So
Jerry, sorry to interrupt for the umpteenth time, but a suggestion has been made by Franklin Hu, which is so elementary. I don't know why I or nobody else thought of it. He suggests that if you turn off your camera, you will improve
okay.
the audio by having a greater bandwidth. Would you like to try that?
How should I turn it off?
So
How do I turn it off?
can you on your screen you should have stop cam after mute
Okay.
at the bottom banner. Okay, now just speak. See, is it any better?
Can you hear me?
Yeah, I think it's better without the camera.
I think
You've got the camera
that
back
took
again now.
away my voice.
Why have you put the camera on
I think that
again?
took away
It was
my
better when
voice.
it was off.
I don't know if you can hear me without the camera though.
We can.
Should I try
Yes, of
again
course.
and see if you can hear me?
Try again. Yeah. Now speak up.
Can you hear me? You can hear
Yeah,
me?
we can hear you
Can you
perfectly,
hear
and I
me?
think it's improved without the camera. So I suggest keep it off until we finish the lecture and get into the discussion. Okay. So proceed. Sorry about that, Jerry. Thanks very much.
Oh, that's all right. Thank you. So yes, Fitzgerald thought that the ether pushes objects to short. Unusual, since the invisible the ether is invisible and currently undetectable as far as I know. Uh, if the ether is detected, one would reply. I think Michelson and Morley had the idea that the ether was fixed and stationary, and that it was meant to propagate light. So, some ether these days is is flowing around, and so, some ideas of ether is that it consists of gravitational fields or plasma or there are quite a few theories sort of how those other types of ethers would push objects to shorten. And of course, it isn't every etherist who believes in length contraction at all anyway. Actually deduced from Fitzgerald's equations that an object that travels fast would also increase in size as it shortens in length, which seems somewhat, those seem sort of opposite ideas, or size would mean that they don't suggest height. In books that I've read, well, I recently heard it suggested that relativistic mass, which is mass increase, isn't really growing mass. They have said that it's instead just that it's the energy that is in there, the force that it would impact. The way you throw a baseball and it hits a wall, for instance, the impact that, and that I would consider that inertial or even kinetic energy. And I'm quite sure in books I've read, they have suggested, like in much older books, they suggest that mass actually grows in size. So anyhow, experiments done with charged particles, which seem to prove mass increase, where they observed the particles, and they noticed that the inertia. They weren't observing any visible increase in size. They were observing the particle's inertia, which is a completely different effect. So Fitzgerald's idea of length contraction was accepted without evidence at the time, because they knew it was allegedly derived by the idea of mass increase, which many thought was proved. So length contraction was sort of accepted on default. Anyhow, okay. Here's the last slide.
Because the sound has deteriorated even with your camera off, I'm afraid, Jerry. So we're going to have to finish. What we could do is we could actually put up the slides and go through them slowly. But anyway, go ahead and finish now, by all means, if that's the last slide.
Oh, okay. The relativity of simultaneity. The theory states that two given events observed as synchronous the points of view of observers in other positions. such as if there was a lightning bolt. Say there were two lightning bolts right next to each other that happened to be synchronized. One observer might see them synchronized, though an observer in another position, say a mile away, would see one lightning flash before the other. So that there would be that difference depending on which event occurs first. However, though, the velocity of light is so fast that it would seem impossible to see such a difference at close proximity, such as on Earth, such as a lightning bolt on Earth, because light travels, of course, just unimaginably fast. So, anyhow, there isn't experimental evidence for this, though they probably have tried experiments. I mean, I don't see why they wouldn't, though, because it doesn't seem about. Yes, okay. So, actually, that is all. I have way more notes for anyone who would like to read more about all this, or I could even do a different presentation through Zoom sometime soon to cover all the. So anyway, Ian, thanks so much. That's the end of this presentation. I guess I'm open to comments and questions, or
please put your camera back. Thanks, Jerry. Thank you very much for struggling with us. I'm sorry if I was interrupting and rushing you on. You're not overdue by any means. In fact, you'd have 15 more minutes plus. But it's just the sound quality was so bad.
Okay.
The sound quality was so bad that I think on any broadcasting station, they would just stop the broadcast. But I thought now that we have you and you've gone to the trouble of making up the slides.
I was thinking that myself.
And we can use those as a discussion point anyway. We can request that you bring up some of the slides because they were most interesting. Well, basically, you have gone through the essentials of the special theory of relativity and just questioned them, I suppose. And you've said, I think, that there's no experimental evidence. Now that's contrary to what is generally believed by professional scientists and the public at large, that the special theory of relativity is so well verified by experiments that if we find something that apparently contradicts it, we'd have to look for some other explanation. But you're questioning it, and you're questioning things like the Fitzgerald
which
contraction.
Which specific theory doesn't have which one were you referring to that doesn't have evidence?
Well, you said it in a number of places, haven't you? You've questioned even mass increase. You've talked about inertia.
Well,
I don't have.
I would say, I would say there. Well, my personal view is that there is adequate evidence.
No, you're breaking up. I'm afraid very badly, Jerry. It's just
that's my
people are can't hear you at all.
Hello?
The issue is the slides, not the video. I don't know what that is. The slides seem all right. We could capture
this computer is so old.
Yeah, that's
Windows
the problem.
8.
And
it says Windows 8.
What is 2008? Yeah, I don't consider that old because I like to keep things wrong. But in today's environment, it probably is, and that's what's causing all the problems. And we've even had a remark there that you can question the basics of the special theory of relativity, but you can't get an internet connection working. Well, somebody would make a joke like that, but nevertheless, you can do that. It was said, by the way, that Einstein, he couldn't fix a toaster or something like that. He was completely impractical. So maybe that's partly the answer. The problem is StreamYard. I don't know about that. I don't think so. We could try a Zoom call, but I think we'd have the same problem. I think there's a fundamental problem in the transmission.
Yeah, that's what I was thinking. I feel so terrible.
Yeah, so I'll tell you, I think it's Roger Anderson looking for the floor. But if you permit me, I'll just spend a moment seeing is there anything really salient in the comments that we need to deal with before I'll ask you to come up. So let me see. Yeah, there's a lot of comments here.
Hello?
Yeah, no, I'm just looking through the comments. If you just, it's sort of my style, which I think some people find a bit boring. But if you just give me a minute or two, just
that's
check through
perfectly
the
fine.
comments, because I have been reading them as they've gone through. I mean, for example, Cerna hepta dimensional space is making comments, Billio. But he's got about 2,000 views, ideas in his comments, and that's great. But Cerna, we just can't deal with those in a conference of this nature. You've got too many ideas. We might ask you to give a presentation at some stage. But if you have one very specific point you want to make, we'll deal with it. So I'm looking at your comments. Robert, well, okay. Put you in the hot seat again. Robert K has said special relativity is a mathematical theory of space and time. Where is the math that supports your theory? How would you deal with that? So I think he's questioning, and I'm not saying I agree with him.
That's a huge discussion.
Math, you've deliberately.
Oh, I know. I mean, there's a lot to that question. I would say that I would say there's math inherent in language.
See, I think you're not being given a fair
opportunity. You're using mathematical terms.
We can't hear you. The system is breaking up, so it sounds as if you can't answer it. I'm sure you have a very good answer to that, but
oh no, I can't.
You're snookered, if you like, by the inability of the sound to come through clearly. I do know from a professional broadcast on the radio, as soon as that happens, they stop the interviewing and they will try to get a better line. But in this case, it probably isn't possible. Question of the constancy of speed, and I had a bit of a conversation.
The math itself doesn't prove the theory.
Say again.
Okay.
What didn't prove the theory? Okay. Robert K is talking about Maxwell's theory making C constant. I question that. Okay. Right. We'll Jim Morrison has come in again about the ECI frame being the local ether frame, and the lab is only going at about 300.
The math itself doesn't prove the theory. The math describes how the theory goes.
But it's an auxiliary system. I mean, one can talk in language, and to be able to do that actually is very, very important, because as Lord Rutherford said, he said a man doesn't understand his theory. Sorry, this is quite an unpolitically correct expression, but he was writing, in the 30s. It doesn't understand his theory properly unless he can actually explain the elements to a barmaid, presumably without any maths. But we also, a person, might like the mathematics. So, do you have any mathematics behind this? If somebody like me or whoever it was asking Robert there asked for it. Okay. Okay. These are just statements, really. Most of these points are statements, not questions for you.
I don't think
but I
math
think
is
there may be questions from the
required.
Greek.
Or just prove it. I think math is required.
Yeah, well, I think Roger said he is discussing why SR makes no sense to him. And you have every right as a thinking person, and I know you've made a lot of comments on all our multiplicity of lectures, including ones with quite complex mathematics. And your comments are normally very, very apt, I think, anyway. So you've every right to say why SR makes no sense. Okay. Now, so Roger Anderton, yeah, I'm going to bring you up now. I wasn't clear for the moment, Roger, because you're logging in as administrator, but that's fine. I've done.
It didn't work properly for me logging into StreamYard. I'm sorry, Joe, what's happened to you. StreamYard has played me up a lot in the past. It doesn't like all computers.
Because I know you, Roger, did a rehearsal with Jerry. I think you spent up to an hour beforehand, for which I thank you very much. I came in just 15 minutes before, and everything seemed fine.
He's just trying to log it onto the StreamYard system at a lot of problems. Because
somebody's made a comment. Yeah. Maybe
I think there's
can Jerry call in via telephone to talk. Can that be done?
Yeah.
Roger, can he?
I don't know. I don't know. I don't understand the telephone system.
I don't know how.
For logging on the StreamYard, but no, StreamYard doesn't like all computers. It's very nasty to people. It's sort of like what I've used it in the past. And it's really plain.
The next time I give a presentation, I'll have a new computer.
Yeah, you need a new computer, unfortunately.
I think StreamYard doesn't work well even with new computers.
Probably, that's probably right as well. I don't think Zoom is much friendlier, so that's why I wanted to sort of like set up a anti-relativity Zoom meeting thing. But at the moment we've got Zoom meetings every Sunday, and that's
I was skeptical, I must confess, but Jim Keane has stated, and he's probably correct. He said maybe StreamYard is more CPU intensive than Zoom, since Jerry has heard okay on Zoom sessions.
Yeah, Zoom is much friendlier. Zoom is a much friendlier system. So
it's more forgiving with old hardware.
It's able to work better with all people.
So what we might do, via other Zoom sessions run by Harry or other ones we can run, we might invite you back.
But getting on to the relativity issue.
So what else did you want to say, Jim?
Wait, we get on now onto the relativity.
The floor as well.
My main gripe with relativity is it's always moving goalposts, and what that I mean is keeps making changes. You've got relativity keeps changing what it's saying, and you're right that relativity used to talk about mass increase, and when I was doing relativity, that's what they taught me. But if you talk to somebody who does relativity now, I've been to courses where they teach it now, and they say there's no mass increase. They've changed their position on mass increase. Okay. They don't say.
I have heard that.
Yeah. So that's my right. So they moved the goalpost. They've said.
So my understanding is Roger, makes this point continuously that they're changing their position. It's a moving target. Do you think that's an important point to make, Jerry?
So you're attacking an old version of relativity, and they've
once heard someone say that mass increase.
They've moved their goalposts since then. They've changed their position. They're not.
So is this something that you, Jerry, have looked at as well, or when Roger raised it, was it something new to you? The concept that it wasn't a fixed theory. Well, all theories are developing in some sense, but I suppose this is a major
mass problem. Increase.
Well, just generally,
mass increase.
They don't have mass increase anymore.
Well, I've thought extensively. I've read a lot of books on relativity, most of them not even all the way through, but I've thought extensively about the ideas, and I've written extensively and had countless debates and conversations through the years. So I know the way the theory goes, but I don't know the mathematics, I have to admit. I don't think mathematics is required to disprove the theory, though.
Yeah, there's a physicist on YouTube, Don Lincoln, Dr. Don Lincoln, and he's very high up, and he does a video and he says there's no mass increase, and so people who used to teach there was mass increase, they got it wrong, basically. So that it's not the same theory anymore. But the supposedly the big experts on the subject, like Don Lincoln, are saying there's no mass increase, even though it's in lots of textbooks 50 or 60 years ago saying there's mass increase. They're now saying there isn't. And so
yeah, well, my understanding is that is still an element. But the other question is they talk about, I've forgotten the expression they use, as viewed or real.
Yeah.
That's the other thing. And actually, some of the theories say that if you took a picture of a moving object, it would appear to be the same length because of the photographic exigencies would actually compensate for the Fitzgerald-Lorentz contraction. So it's all very complex.
On Carl Sagan's the original Cosmos series with Carl Sagan, there was the experiment of someone traveling around the city on a motorbike, and he was saying how it looks like blue shifted if they go in a certain way, and
red shift the other way.
Like,
yeah. Well, thanks very much, Roger. You can come. We've time this time actually. So if you wish to come back later, we can do that. So if that's all right for the moment.
I think
the show was there's like length contraction where it's short.
Yeah.
Anyway, he had suggested that in the video, in the Cosmos videos. However, Einstein didn't seem to have any reason to accept length contraction and mass increase, because they didn't connect at all with special relativity. They're sort of, I mean, most of the etherists today accept length contraction. I think he might have accepted because it was already accepted within the scientific community at the time. Just a thought, a possibility.
Yeah, I mean, perhaps the nut, the kernel of the question of the mathematics versus description and so on is that most of classical physics, we've used complex mathematical tools, which you have to be trained in mathematics to understand.
Oh,
but
yes.
they generally
don't
don't
deny
go
whatsoever that math is
if you took down Lamb's hydrodynamics and you found that certain when the wind exceeds a certain value, you get the gravity waves coming in, the value will be such and such, and you'd say that probably makes sense. I've experienced that in ponds and so on, even though he's solved very complex partial differential equations to get that result. The difference with something like SRT and GRT is that they go against common sense. Now it's very much so. Now that in itself isn't something that's fatal, but it's questionable, and that's why a person who doesn't have the mathematical tools,
I think I missed a lot of what you were saying.
You what? You agree or disagree? Yeah.
I think I missed a lot of what you were saying. A lot of it was cut off.
Yeah.
I didn't get your point. I'm sorry.
No, my point, it's maybe the comment of Robert Kay, which is a fine comment. I mean, it's a very well-made comment. I've no problem with him. But he was saying, do you have a mathematical theory? And you're really using everyday conceptions and so on and common sense. For example, I think you alluded obliquely to Dingle's concern that if there's reciprocity, if there's no preferred frame,
you can apply mathematics to many
clock
things.
A is slower than clock B, but clock B is also slower. Now that is just a contradiction in terms. It cannot be right. So you have to get over it some way. And I'm saying that this arises with SRT and GRT. It doesn't arise with Lagrange Hamiltonian equations, because they're basically just an extension of Newton's principles, which are in accord with common sense. You could say, well, maybe Galileo's idea that it's independent of the mass, the acceleration due to gravity. But on the other hand, once you understand the basic principle, it's fine, and you can do it. You can go up to the Tower of Leaning Tower of Pisa and drop objects and experiment. But with Einstein, you have these very strange experiments, and you yourself have alluded to them, because you talked about some of the experiments. And I think I don't know if it was you, Jerry, or in the comment there was a reference to the clocks changing. I think you referred to it actually, and I was thinking of the Haffel-Keating experiment. And that's highly questionable. So, but could I bring in Nick, because he's been asking? Let me just see, because I've been ignoring the. I think he put a statement in. He didn't put his hand up. So, Nick Percival, I'm going to bring you up, and you have some contribution. Go ahead, please. You're mute. You're mute, Nick. Can't hear you.
Hi, Nick.
I'd ask Jerry to mute himself while I'm speaking, as the sound breakup just interferes with the conversation.
He's done that.
All right.
First of all, I'd like to congratulate Jerry for being a critical thinker, and even if someone couldn't hear a word, he has put up some very penetrating questions on his slides that to any other critical thinker should either cause them to agree that that's problematic, or at least cause them to think about it. And as you alluded to, Ian, sometimes opponents of criticism to special relativity will say things like, oh, if you can't get the sound right, you have no, that throws out your credibility totally. That just indicates that the person who said that has a closed mind, and they will grasp at any straw to preserve their belief system. Just a few comments about the presentation itself. Jeremy was talking about, in his first slide, it being a problem that there is no absolute universal frame. I would disagree with that, and I would think that Einstein would too. Remember that Einstein, who was a critical thinker, famously said that all physics is local. Now, obviously, people in quantum mechanics who believe in entanglement might disagree with that, but I think that's a very good point. Unless you can talk about in terms of two physical entities interacting, then you've really got, sort of a vague and mystical explanation of things, which unfortunately most of special relativity is guilty of. So, and I think the GPS data says that looking for a universal frame is incorrect, particularly in terms of clock retardation.
Again, I apologize so profusely for this.
So I would just make that point. Regarding time dilation, some things like length contraction and mass increase are very difficult to discuss, because then they bring in relative simultaneity. But the great thing about time dilation is that when you send out a clock and it comes back, unlike length contraction, there's evidence, cumulative evidence of the fact that something has happened. And it turns out from GPS and their atomic clocks that motion with respect to a single unique non-inertial frame, the GPI frame, they call it inertial, but even though it's not technically inertial, because it's orbiting the sun, and the sun is moving with respect to the galaxy, et cetera, et cetera. So but it's not, laws of physics are not the absolute same and observer-centric. There are physical effects with motion with respect to a single preferred frame in time dilation. And in fact, if GPS used some other arbitrary inertial frame, which special relativity claims they should be able to do, they would be sending people into lakes and rivers and neighbors' houses. So GPS, as Ron Hatch,
suggests that
the expert on special relativity, on GPS, says that GPS data categorically disproves special relativity. So just moving on, Jerry talked about metronomes, and that is very interesting data, but it has nothing to do with special relativity, time dilation, or even Lorenz's clock retardation. It actually is an interesting, but it is an interesting disproof of time dilation, because if time dilation was accurate, then everything would slow down to the same degree. And metronomes do not slow down to the same degree as atomic clocks, or the same degree as pendulum clocks, or is the same degree as hourglasses. So it's all, in fact, there are a whole lot of atomic processes that slow down at different rates depending upon their velocity. It just seems that atomic processes slow down at that Lorentzian factor rate, and that's also proven, shown within CNPS's. The what's the name of that accelerator in Europe? CERN, CERN, the CERN accelerator for particle decay and whatnot, as has been pointed out by John Field, the expert in that area. Jerry talked about max velocity, and one pretty simple thing was, okay, let's assume that I can only go with maximum speed to the east at c, and by relativity principle, you can only go to the west with maximum speed c. But then special relativity says that the maximum speed, relative speed between the guy going east and the guy going west is c. So c plus c equals c in relativity, special relativity. So there's another one of its inherent logic contradictions.
Okay.
And relative simultaneity, it's interesting that quite a few relativists have said, yes, we don't agree that there is a relative to the simultaneity, and they try to construct it. They aren't relativists, but they say that the mainstream has got it all wrong. So there are, I think, many degrees of making steps towards understanding that relativity does indeed have problems, and it doesn't necessarily mean that the ardent believers in special relativity will immediately see light, but they should at least go into critical thinking mode like Jerry has. One last point, I think, for Ian and Roger and Franklin. I would recommend that we not put this up as a publicly viewable talk, because then you get all these talks about, oh, these guys are so incompetent they can't get their sound right. and noise like that, and I just assume, have another one done and put that up in its place. Because all the regulars who have seen it and will be able to talk and whatnot, and right now after myself, and make whatever points, but I'm not dictating that. I'm just suggesting that.
Well, if I may make just a comment on that quickly, this automatically will go up onto YouTube, Nick. I understand. Yeah. So there is a possibility for your good services, maybe.
Yeah.
If Jerry agrees, and we all agree, to delete the formal part of the lecture and to keep the discussion.
Well,
that's fine with me. And then later, when Jerry has solved the sound problem, we'll be able to put up his presentation in with good sound.
Yeah.
Okay. Yeah. So Jerry, you could look at that for us.
I was interested.
So would you like to address some of the points, Nick?
I was interested to read. About well, he mentioned a few of them. Was starting with a preferred frame, and I mean I guess some say it's the ether course, which Nick has a certain view of the ether, which I think is gravitational waves or fields, or anyway. I would say the ether, if the ether exists, it's part of the universe. It isn't something that the universe exists in. It's something, whether it's physically tangible or physical, it affects it interacts. So it only seems that way dealing with when it comes to the velocity of light, like as far as determining like how far fast it goes relative to the ether. As far as how physical objects exist and travel relative to each other, that's the part of Galilean relativity that I accept as wholeheartedly true. That
so if there's a signal going east or a signal going west, do you believe that the relative speed of those signals is the sum of the two speeds, or is a maximum c? I mean, you expressed what the conception of SRT is, but you didn't actually say whether you totally disagree with it. That's what I'm pushing you a bit now. Do you disagree with that, Jerry? That c is an absolute maximum. Yourself, I mean, you've raised
I'm sort of unsure of the question. I don't know if you're speaking of the two-way velocity of light or.
Well, forget about the two-way for the moment. Just Nick's example was you have a beam going east and a beam going west. Now, it doesn't matter exactly, whether you take those to be the same value or take into account the Earth's spin. But
one object travels away and the other travels the opposite direction.
Yes.
If you have two motor cars, it's difficult to understand completely because it keeps breaking up. I would love to discuss this later, Nick, for sure. Through email
well,
or
we can have a discussion.
Okay. I'll just make a comment. I had the good fortune of discussing the GPS data with Ron Hatch, who was considered the world expert on the GPS data for a decade. And if there is an ether, and I think there is an ether, then the ether is just very local. It's not a single absolute frame for ether. In the vicinity of the Earth, the ether frame is the GCI frame. Also, if you have two signals going in the opposite direction on Earth, the GPS data says that the relative velocity of those two is 2c. And that the velocity, they have to account for the velocity of the receiver vis-a-vis the GCI frame to correctly come up with the location of the receiver. So the speed of light is c in the c with respect to the GCI frame in the vicinity of the Earth, and that's done with really great precision.
As far as the GCI frame, the GCI frame, I've heard that some say that the constancy of velocity of light is only present within the GCI frame, and that the further you go out, where gravity sort of fades away eventually, that there isn't the constancy of the velocity of light. That though, if that's true, how is it different? How does light propagate there if it isn't? And how would that work? I mean, you probably don't accept that, but I've heard that though.
On the other point
gathered all
that
that,
raised about the time, whatever you want to call it, dilation or whatever, and the different behavior of an atomic clock vis-a-vis other times of clock, like pendulums or the hourglass. Now, I agree with that. I'm fully in agreement with you. But you said there were experiments to establish that, and I don't know of any experiments that are. I mean, they'd be very, very complex experiments looking at very, very small differences in time to establish that an hourglass or a spring clock or a pendulum it didn't behave in the same way as an atomic clock. I believe theoretically that is true, but I don't have any experiments that have established that, Nick.
Oh, yes. Jerry referenced the metronome experiments, which are pretty well known. Hour clocks and pendulum clocks will speed up with increased speed rather than slow down. Let's see what else there is. There's a whole slew of stuff.
We know,
and we know all sorts of macroscopic processes do not follow special relativity's prediction in time dilation.
Yeah. Well, I mean, I'm just being devil's advocate. If you could get those experiments, they would in themselves be disproof of special relativity. If you could prove by experiment that a pendulum clock, now I'm probably not aware of something that you are there, but a pendulum clock doesn't lose time, well, then that's a contradiction. And you'll have to have the relativists either inventing a new theory to explain it or conceding that time dilation doesn't exist.
Yep.
And it's merely the behavior of atoms. Okay, that's something we could look at. So anything else? I think some of the points we'll have to discuss more in more detail, probably over Zoom. It's too bad to have Jerry address them all. Unfortunately.
Let me say quickly.
I'd like to, Jerry.
Chat. Can you hear me?
If you,
I don't know if you can hear me.
And maybe I can. No, you're breaking up.
One more point. Sherry said that I didn't mention something about preferred friends. Well, all the things I didn't mention, I probably agree with Sherry. So I was only bringing up those things that I thought needed extra mention.
So, I can certainly help after the lecture. If Jerry, you're taking some notes or something, like maybe you can address some of these points, which are very important, in an email to us. Just pop out a note, because I know you've written a couple of good emails.
Oh, so absolutely. I could send you all of my notes that I have prepared that I didn't get to read.
Yeah, you're not doing yourself justice by the poor audio quality, and it's a shame, So, anything else for the moment, Nick, or can we bring you down for the moment? See if there's anybody else want to come in.
Yes, so great critical thinking, Jerry. Appreciate it.
I agree. Thank you. That's important to stress that. We do.
Thanks so much, Nick.
We do welcome anybody, as I say, questioning things, and you are a critical thinker, so we can permit you to enter that Hall of Fame, and that's an important accolade, I think. Now, is there anybody else in the green room? Slobodan, are you moving your hand, or you're just thinking? I thought you were asking for the floor. You seem to be on some call. Okay. I'm not sure. I thought Slobodan was asking for the floor, but I'm not sure if he is. Roger wants back. Okay, Roger. I think Slobodan wants back, but he's too late. We'll bring him in after Roger's finished. Roger, you're up again.
Yeah, thank you. Yeah, Nick's brought up some good points, but I think on the clock one, the assumption is that all clocks work the same way, and the kind of standard is the atomic clock. That's a really precise clock. And if you had another clock which didn't agree with that, they would probably get around that by saying that clock wasn't operating properly or some sort of problem with it. So they would still set with their beliefs. It's just a bit more moving the goalpost on to say, oh, there's some timekeeping methods that don't work properly. But anyway, can I get back to this point, which I think way back now, which was Ian was saying about relativity being counterintuitive. And the way the mainstream tries to justify that is, well, it may be counterintuitive, but the mathematics works. Well, I think people like Harry Ricker and to myself to some extent look to the mathematics, and the mathematics doesn't really make sense either. So what they say about relativity doesn't make sense.
Well, yeah, I definitely heard that thanks to you and others.
The mathematics doesn't make sense, and they sort of like what they do with the mathematics is what I call moving goalposts again. They kind of move things around a bit, they muddle it up, and so what they say, they move the goalpost on, and then the mathematics they move the goalpost on, and then what they say about experiments doesn't really hold true. They make claims about experiments showing this and that, and you can look at it and say, no, you don't agree with how they're interpreting those experiments. So they've got a perfect mess, really, relativity. It's kind of like closed.
Well,
what they believe.
Yeah, perhaps is a particular interpretation, and then they develop the maths based on that interpretation.
Yeah.
So you could argue, that. So, but the interpretation, to my view, anyway, I'm giving my own personal opinion now, is more than the two postulates which Jerry talked about. I mean, for my own part, I agree with both postulates of the special theory of relativity, as expressed in the original paper. The first one is that, the laws of physics basically are the same. Certainly for inertial systems moving at constant velocity. And secondly, the speed of an electromagnetic wave is independent of the speed of its source. That's true. But the speed of any wave is actually the speed of its source. But then what they've done is they've said, okay, there's reciprocity, so it also must be independent of the speed of the observer. Now, that's not true.
Mm-hmm.
So they've really added more than the two postulates. The two postulates, Jerry said he agreed with the first postulate, I think, and maybe you said you didn't agree with the second. Is that the point?
Yeah,
but I think they've interpreted it in an incorrect way. The way it's expressed in the 1905
I have
paper.
many questions about the second postulate.
What was that?
Well, time dilation was meant to account for the second postulate. That was to account for the unaccounted for distance.
So we were asking you, and I'm not quite clear on your position, whether you accept the second postulate yourself, Jerry, or are you still questioning it, or do you?
I don't.
You don't. Okay. But you don't accept it in the extended sense.
I don't accept time dilation as an explanation.
Right.
I have many questions.
Well, they claim the experiments show it, but those experiments.
I'm highly skeptical.
Yeah, but their experiments which they claim show time dilation, which I would prefer to call clock dilation, is really based on the belief of assuming that postulate. So it's circular again, really.
Yeah.
So the whole thing's really messed up. They've got their closed belief on it. And when you try to point out a mistake, what they do is they move the goalposts. So that's my little comment. I think we're better talking on Zoom than on here.
Yeah.
We've
Okay,
had,
Roger. Well, thanks for that. For the
we've
moment.
had
Thanks so
a lot
much,
of
Roger.
we've had a lot of problems on this other sessions and on StreamYard, and sort of like.
Yeah, well, it's unfortunate because Jerry has gone to considerable trouble. I think he's been helped by his nephew or something, but in making up these slides, which are very valuable in themselves. I have read every line.
Yeah.
Probably most of you have. It's been, I think it's been very refreshing to go back to the fundamentals of relativity.
Yeah.
And despite the questions of mathematicians that, we really ought to introduce mathematical expressions, I say, no, let's once do this. And Jerry has done that very well. But we have been snookered by the atrocious stand quality. And anybody else would have probably stopped the lecture and said, we'll deal with it some other time. But I was so enthusiastic about it that I thought we'd continue. And we have the slides there. So thanks, Roger. I'll perhaps bring Slobodan on. Thank you again. So I'm not 100% sure that you were asking for the floor, but I know you have some views on this, Slobodan.
I did a couple of times, but
If you could speak a bit louder, please.
So yes, I did on a couple of occasions. So
you're very soft. Speak slowly and louder, please.
Yeah. So the more talk and discussion go on, the more reason I have to raise my hand. Although initially I wanted to point out very basic way to refute the special theory of relativity. Jerry, now I agree with you. I mean that you don't accept the second postulate, and the people are asking about math. It's very simple. There is no need for big math or some complicated math. The basic assumption for Maxwell-Morley experiment was the undulatory propagation of light in ether. That means the same mechanism as is the case for the sound in the air. That seems to be one thing, to be a wrong assumption, and now the results, at least those first measurements, results, come from the fact actually that the light and transverse rays, maybe also not longitudinal, they propagate emissionally, like Ritz emission theory, or in simple terms, Newtonian's corpuscular theory, and the kind of emission. So the velocity of transmitter impacts the velocity of propagation of light and transverse electromagnetic waves. And look, Voigt did excellent, ingenious transformations for that undulatory case. And if special theory of relativity would be relying on that, then one could be in dilemma whether to accept or not. In undulatory theory, the wavefronts accumulate ahead of the moving transmitter. In the emission theory, they accumulate on the other back side of the transmitter that moves, supposedly with respect to the unmoving platform. And Minkowski transformation, Minkowski invariant, Lorentz transformations, Einstein transformation do not have any physical, support. And by very that fact, they are totally unphysical and untenable, cannot be considered, as a theory or as a mechanism. Now, out of it came all those things, But Lorentz misused Voigt transformations in order to fit his theory, his Fischer's contraction theory. There's a very big problem. And later those time dilations, the mass increase and things like that, mass increase is totally heterodynamical or fluid dynamical mechanical mechanism effect that you cannot accelerate because of those interactions of fluid and the fluid reduced by the moving body and things like that. But maybe most important thing, I mean, I don't know, maybe Ron Hatch would not be that good example for that. But in GPS, nothing of the special theory of relativity is being used. Only the general relativistic correction of clocks that considering the way the GPS is operating doesn't have any impact on the operability.
Oh, okay.
So, it's just one more thing, you know. When they decided for the that the emission theory cannot support the binary stars observations, they did not prove that special theory of relativity or undulatory mechanism, at least, could do that. And it turns out that neither of them can explain the experiment, as shown by Milankovic, that guy that is renowned for the climate changes theory and things like that. But if you take into account the re-emission, you know, Dr. Dowdy actually has been advocating emission theory and re-emission theory. Remember, his name Dowdy, yeah, Dowdy.
Oh, Dowdy, yeah.
Dowdy.
Yeah.
Up to recently, I could not figure out. I mean, that densifying of fronts on the rear side of the back side of the moving transmitter and things like that.
I think he talks about re-emission.
Re-emission.
Yeah.
So, you know, or extinction length. There were some guys from 100 years ago, including that Leonard, who is
Leonard, yes.
He also had emission theory introduced maybe some 100 years ago. So emission theory is mechanism for light propagation and transversal electromagnetic waves. And together with re-emission, everything can be explained. And really, you know, I very often wonder why people are considering that much special theory of relativity. It's so simple to refute. So,
Okay.
Minkowski invariant is totally unphysical because it falls between undulatory theory mechanism and the emissional mechanism.
What did you say? It's unphysical.
Unphysical.
Okay.
What is the physical mechanism of propagation? That you have the same wavefronts when you have when you look at the coordinate system tied to the transmitter and the coordinate system that is on the moving platform. You know, same wavefront.
Okay. So maybe Jerry, you know, you're raising quite a number of very interesting points. Maybe Jerry might like to address if those are if that's the conclusion of your contribution, Slobodan. Jerry, yes, would you like to address any of the points Slobodan raises? Or again, is this a question for email? I know you're an avid communicator, Slobodan, so you might care to raise some of these points with Jerry, and perhaps he'll respond to you. I know he will.
Maybe. I mean, usually, after this discussion, something like that.
Okay. Well, thanks very much for your contribution for the moment. I'll bring you down if I may, because I just bring this to your attention, Jerry. This gentleman whom I haven't seen before, Yosef. Too many words and not enough math. Again, back to this question. LT operates in the domain of space-time. LT is a transformation that preserves the form of the wave equation. This results in a constant speed of light. So that's the orthodox expression of you know, the existence of LT and the constancy of the speed of light, and maybe it being a maximum value attainable. how would you answer that? Would you say yes, that's one theory, and I'm questioning it, or?
No, there doesn't seem any understanding to the constant velocity of light there. I mean,
Again, you're back to the physicality.
I
Yeah.
mean, time dilation is meant to explain. Yeah.
Well, let
I
me
mean,
give
too
you
many
my
words.
personal
I
view
mean, I
on
think
it.
words
I'll
and
impose
concepts
myself. My
explain
own
a lot.
view is that yes, the LT does operate so, but it's merely a trick. It's a mathematical artifice. It just happens to give you a invariance in the wave equation,
Lorentz transformation.
and it has no physical significance at all, and you know, resulting in a constant speed of light and all that sort of nonsense. I would say that one can reach invariance by a system which is not as contradictory. In fact, it's intuitive, it's heuristic even, and it is this. I don't want to give a lecture now, I'll just stop in a moment. But my explanation is this. It is using the total convective derivatives in the Maxwellian equations of electromagnetism instead of using the partial derivatives, exactly as is done in hydrodynamics. You get this total derivative and you get the equations, and you will actually find, if you work out the complex mathematics, that you get the same result as the LT. You get invariance of the wave equation without all these nonsensical assumptions. So do you think I've ranted a bit? Do you think what I said there might be a reasonable answer to that question,
That's
or do you think
Lorentz
I'm over the wall?
transformation, right?
What's your own view, Jerry? Or you have to kick the touch a moment because you perhaps haven't thought about that in detail. Have you?
I don't really believe that space and time are inherently connected. Well, they
Yeah.
occur
Okay.
simultaneously, and one can't exist without the other. However, though, there is many reasons to combine them into one theory. They're separate concepts with their own
Okay. Well,
distinguishable
that's an important
definition.
thing to get out of you.
Oh,
So
I,
I
I
have one
didn't
or
quite
two
gather
things to
everything that
do,
you
but
meant. I definitely agree with some, and these conditions today are just horrible to.
okay.
Yeah,
I have one or two administrative things to do before we terminate today. So I'm going to have to give myself another few minutes for those. I just want to see, is there anybody else? There are people who have, they've cut off their actually, in some cases, the mic, but in most cases, the video. So I'm just wondering if, say, James Keane and Harry Ricker seem to be there, although Harry's having connection problems. And Jim, if you don't mind, you've made a
can I
couple of
say something
comments
real
there
quick?
I didn't deal with in detail. And I know you referred to the type of Michelson Gale type experiment done in the northern hemisphere and the southern hemisphere. And so you might want to raise some of those points to Jerry, and see, is he aware of them, and what he thinks, if anything.
I'm sorry. What are you referring to?
Sorry, I'm apologizing in a way because you put a couple of comments in, and you said, "Oh, both in Berlin and in Christchurch or something, they found relative spin of the Earth and the ether."
I'd heard that there's Zoom calls later on.
Sorry.
Okay, that's administrative. It's really Roger who might have to explain that, particularly if I don't explain more. I think Roger is having a call at an unearthly hour from my point of view, but to discuss a lecture that's held. So I think it might be a new phenomenon because Harry Ricker's Sunday sessions on cosmology, which I believe are continuing, they're having one tomorrow. We might spend 10 or 15 minutes just having a bit of a post-mortem on what happened the day before. So he does address that. So I don't know in what detail Roger's going to go. I think he'll probably give a lot of his own views. He'll probably also suggest how we might resolve the practical problems of using StreamYard and so on. So I'm not actually sure what the agenda is, but I think it's probably a mixture of all those. But I'm asking Jim because Jim, I know Jim is actually going to be a speaker. I think he may be our next speaker. In fact, Jim,
2
you're
weeks.
coming up very soon. We're going to impose upon you. And this
Yeah.
idea that NASA is very unlikely to adopt. In fact, you have a cursor, don't you? You know this. What's his name? That man. That he was a sort of like a jack of all trades and a master of all. What's his name? Zapfi. Have you heard of him?
Say again.
Carl Zapfi.
Yeah, actually, Harry has noticed that he
Yeah.
proposed it, and I guess he was somewhat close. And his idea was that it had something to do with the ionosphere.
Right.
My point is that, as Nick pointed out, if we consider this ECI the preferred or privileged reference frame for GPS, that it should also be for MMX. Essentially, that the speed of the lab, this is due to the rotation of the Earth with respect to the ECI or GCI, and which means that it would be much slower than what was looked for or expected. The 30,000 meters per second that the MMXs have been designed for have it wrong. It's only 300.
Like 2 orders of magnitude difference.
And even more because it's velocity squared.
Right.
It's
1,000
times. It's 1,000th
Well,
or 4,000.
What type of
4,000.
result
10,000.
would you look for?
Sorry.
Say again, Jerry. My understanding is we're looking for
As far as having a Michael Center Morley experiment
in space.
Well, that's
you say preferably in a satellite orbiting the sun, don't you say that?
because we're saying that the local ether, this preferred reference frame local to the Earth, does dissipate or transfer to the sun's local ether. So the sun, the solar system becomes the privileged reference frame outside of the Earth's influence, about 1 million kilometers. So that would respond to one of your points, Jerry.
What type of result could you expect?
But if what I'm saying is correct, then that explains that the Michelson-Morley experiment null results aren't really known.
What type of reading? Like would it tell you how fast you're going through the ether?
You just need a much more sensitive device. Well, actually, you don't effectively need it because first order experiments like the Sagnac effect don't cancel out the reflection part of the phenomenon that leaves you with v squared over c squared. I can't explain it too quickly, but essentially, Michelson-Morley experiment was not null. It was just too small to detect with the instrument they used. It's a second order instrument versus a first order instrument.
Right.
And that's what screwed up everything. That's what led to length contraction, time dilation, all this crap.
What would it tell us though? Would it tell us how fast the Earth travels through the ether or the position of the ether?
Not inside the Earth. Not in the vicinity of the Earth, because it's like a cocoon that travels with us. You follow that? A halo.
So there's like a bubble of ether around the object.
Around any very massive object, right? But the key difference from other ether theories is that it doesn't rotate with the body. It's fixed direction in space, like the ECI is defined as. So, I don't know. It's hard to explain in a quick point. I just wanted to make the point that, as Nick was saying, that the GCI is the preferred reference frame for first order results like Dagnac and the pseudo range correction of GPS. but that should also apply to the Michelson-Morley experiment. That was my main point.
Yeah. So, Jerry, any? I mean, we'd value your input. I'm sure there will be input because when Jim speaks, you will be inputting your comments and so on. You know, you're obviously
I'm sorry for my computer, everyone.
a person who will look at things from first principles, and that's
Choose
important.
Except
Okay, well, Jim, thank you very much for
Okay.
that. And
there's more on time dilation, but I won't bore you with that for now.
Okay, you save it, will you? Will you
we
tell
can
us?
email if you want.
I'd like to hear your.
I read my papers.
Yeah. Okay.
Okay.
Essentially,
Right.
essentially is effect on the clock itself. It's like temperature. It's not time dilation.
Yeah, in particular, the gamma effect will be on atomic clocks.
Right.
Yeah, because of the way they work. Okay.
And
You're agreeing with it. And I'm having some discussion with Nick about it. We both agree, actually, but I'm just worried about experiments.
Well, I can show you a derivation. I can show you a derivation that gets the gamma factor, sort of by.
Okay, we look forward to that.
Almost. Okay, I'll put that.
Thank you very much, Jim. Thank you.
Right, sure.
Now, well, I think I'm going to have to curtail it now because I want to do one thing, make one or two more announcements, and so if that's all right, we'll leave it. I think both James and Harry are not on the video at the moment. So, ladies and gentlemen, I just one or two comments have come in. All these arguments against that are opinions only. The universe is not based on your opinions or how the universe works. Yeah, that's true, Robert K. But the same thing applies to everybody. You know, we have our opinions, and the mainstream have their opinions, and the universe doesn't care less what opinions we have. We have to make sure that they're the correct ones. Okay, now, so
well, that's our opinion.
Sorry, what was that, Jerry?
Okay.
I didn't hear that.
Wonderful relativity is an opinion. There's alleged evidence, but I would like to talk with Robert K. further if he wants to.
Yeah, Robert K. I'd actually Robert K. is making good points, and he's not shy. And you might want to get into you post. It's just well, they're answering back. That's not me. That's Roger answering back under John Chappelle. So anyway, Robert may care to send a little paragraph out to Jerry or to us, indicating how erroneous we are, and we can deal with that. Now,
well, if the video goes through, we can talk a lot in the comments.
Yeah. Okay, Jerry, I'm going to bring you down, if I may, because I'm going to bring you back and give you an opportunity of just summarizing, give you a minute or two to say how the talk went and what you didn't say, or what the talks were, or what the input was, and so on.
Oh, but before overall, it was atrocious.
Yeah, save that. I'll give you a few minutes uninterrupted, and I'll put myself down. You can say what you want. We hope the sound improves. But what I want to do, ladies and gentlemen, is to inform you about filthy lucre. It's not quite these esoteric theories we're dealing with. And the CNPS obviously requires some subvention to operate. And that is very gratefully obtained partially, not wholly, by membership dues. And that's very much appreciated. However, those dues are not covering the total running costs. And some economies have been made recently, in particular, migrating to a more local server, which is run, under the officership here. And there are, arrangements have been made to transfer that in the event of officers not becoming available and so on. So we're making economies of scale. But what we did under David de Hilster's tutelage in previous years, and in particular recently. There was what do they call it? A fund drive to try to make up the difference, and some monies were made up, which considerably helped in the running over the last year or more. So the same thing has been started again. And if I may, I'm going to say no more. I'm actually not a good salesman. I've never been a good salesman. I would say to people, you should give less, So I'm a terrible salesman, but I'm trying my best. But I'm going to hand over to a little video which takes about 2.5 minutes with your patience, and I'll play it now. If it's up here now. Okay, so here it goes.
Hello, everyone. I'm David D. Hilster, president of the John Chappell Natural Philosophy Society. During the past 2 years, we have used annual fundraising drives in order to keep our organization's presence alive and well on the internet. Both years we have been successful in that the monies collected have been enough to keep us afloat. This year is our 3rd annual online fundraiser, and once again, we are counting on your support. But first, I want to thank everyone who pays their annual memberships through our automatic online system. Your support is vital and provides us with important funds to keep the CNPS afloat. Hopefully, as we continue to grow, we will be gaining more and more automatic memberships so that these fundraising events won't be necessary. But we are not quite there yet. This year, we will be implementing several changes to our online system, several to save money and lower our annual expenses, and another to better our discussion platform. First, we will be moving our websites and databases to another server that has graciously volunteered to host us at a much reduced rate. It currently costs us $1,400 a year for our dedicated server, given that we need complete control over our own software. The new server will give us and allow us that control, but only for $250 a year. Second, we will be moving away from BuddyPress, which is a Facebook-like plugin for WordPress, to using Discourse. BuddyPress was an interesting experiment, but the upkeep of the plugin and its general design don't really fit what we need. What we need is a robust and well-accepted discussion forum, and that is why we'll be moving our online discussions to Discourse. It costs $20 a month, which is half the price of BuddyPress. I think those currently active in our online discussions will find this new platform much more enjoyable and functional. Third, we are moving to a free version of Overleaf, which eliminates a $33 monthly fee. Overleaf was useful for us when we were publishing our own proceedings for conferences, but that is no longer needed. Our goal this year is $2,000, and I hope we can reach that goal. Whatever amount you can donate, it is greatly appreciated and needed. Your membership and donations are vital to keeping our online community of critical thinkers alive and well. To donate, go to fund.naturalphilosophy.org. That is fund, F-U-N-D.naturalphilosophy.org. Thank you, and keep up the amazing work that is driving science forward.
Right. Well, I think that expressed in a far better way than I would be able to the major problem. We'll all very much appreciate your considering that. And you got the website. It's http://fund.naturalphilosophy.org. Fund, F-U-N-D. Okay. Now, so as I often say, the time has caught up on us, but I want to give Jerry the penultimate word. I'll have the ultimate word. I think that's my duty, fortunately or unfortunately for you. So, Jerry, I'm going to give you a moment or two to say whatever you want, good, bad, or indifferent, about how it went. Maybe stress something if you felt that it didn't come through properly. Any question that came in that you want to say anything more on, and then I'll close the meeting officially.
I would say, despite the bad sound quality and the interference and such, I guess I got the main points across, not nearly as effectively as I planned. I didn't get to read a lot of notes. I had paragraphs and paragraphs that I planned to refer to, but I couldn't really revert to my email to read them. I didn't ever transfer them to paper, so I probably should have put them on the actual screen. Anyhow, I wanted to say thanks to David DeHilster actually, because he does a lot for the organization, and I really appreciate him, his guidance. And it's I know he's had some just troubles lately as far as his personal life, but I really admire him a lot. And he had the idea of the distance getting together to organize a book, just a collection of alternate views that are that are maybe more reasonable than mainstream ideas. And I thought was a good idea. Anyway, as far as special relativity goes, I would love later on. I heard suggested that there might be Zoom calls later where we can discuss today's meeting, which I again apologize for how everything it was just terrible. But I want to say thanks, Ian, for having me and everyone else. I appreciate the comments and people wanting to get on and talk, and I welcome further discussion, and maybe I can do another presentation when I get a better computer. Anyway, I guess that's all.
Well, our thanks are due to you, Jerry, for having taken the trouble of giving us the presentation today. I mean, I know that you were a bit green, if I may say so, on your own admission on the production of slides, because you haven't been doing it for maybe your business or whatever, and you did in a short period of time manage to put those slides together. And I dare say, if anybody wants copies of those slides, there are a few slides. And owing to the bad audio, maybe some of it was missed. They can contact Jerry and maybe through us or directly, and we can supply those. Jerry was very apologetic for the poor quality of the sound and other interruptions, but it's really not his fault. It's a problem we're having now. We have had it before. And I'm reasonably lucky. I don't have a bang up-to-date system here, and I'm in the Eastern Hemisphere relative to most of you. But things are working fine, and I can do the Zoom calls as well, so I don't have a problem. But if others do have a problem with StreamYard, they need to make that clear. And maybe you can donate. Here's my own take. If you go into that fund at Natural Philosophy, you can donate an amount of money, and you can put a comment in. So why not put a comment in? You're delighted to help, and you're glad the server's come down. But StreamYard is rubbish, or StreamYard is wonderful, or StreamYard. Put a comment in. You're invited to do that. I'm not saying that you need to donate money to do that. You can do it in other ways directly, but it's another way of making your view known. So if I may again, in addition, Jerry, I'm just reading out Nick's comment. Other pointed at several areas where the empirical data, and while the critics have made comments, none of these comments have been made to try to address these problems. Yeah. Well, my own position is that I welcome somebody like Jerry, who is a person who's always asking questions. I noticed that many of his points in conversation in the dialogue in our Saturday sessions is asking fundamental questions. Well, what is entropy? What is this? What's that? The other? Many of us might be a bit too embarrassed to say that. Oh, I know what entropy is. I'm not going to ask all this. So he's always asking questions, and that's why when I thought there was a possibility that he taught, I said, why not give a talk on that? We've been in discussion for some months actually about this, and we only agreed on the title some weeks ago. I think Robert Kay said it was aptly called a critique because it's not giving all the answers, which is true. We don't claim to do that. He's asking more questions than answering them, and that's what the purpose of philosophy is. I mean, Kant's critique of pure reason is a critique. It's to ask all these questions, and it's up to the scientists to answer them. And unfortunately, many of us in the mainstream are disappointed at the degree of success that the scientists have had in addressing these valid questions which have been raised by the scientists. But anyway, on behalf of CNPS and my behalf as well, because I was moderating today, I do apologize for straining your patience with regard to the bad sound quality. And we're going to have to see what we do about recording. Some of it will be put up, but we'll be discussing that later. And I'm seeing positive comments coming in now. Applause to you, sir. Okay, so I mean, even maybe perversely, the problems we've had today will have highlighted the problems that many have been raising with regard to StreamYard and have been falling on deaf ears. So maybe we'll take a bit more notice of that. So my thanks to you all, those of you in the comment section, the social media, Facebook and YouTube, and in the green room as well. Actually, we had we had one other guy who's actually going to be speaking to us soon, either in December or the new year. But he made a comment, I think, but we didn't get to it. Anyway, if he's looking at the recording, we can come back to that. Thank you all very much in the green room for your contributions. We had actually very good contributions, not from all of you, but just because I didn't have an opportunity of getting you all in, but about 3 of you, and you made very interesting points, which I think we'll have to take into consideration. But last but not least, certainly most, I wish to express our sincere thanks to Jerry for having raised these very fundamental questions, which sometimes the more mathematical, and I'm a mathematician, I love the mathematics, but the more mathematical get into a situation where they can't see the wood for the trees. And Jerry maybe will help to, clarify and elucidate some of those points. So thank you very much for coming today, Jerry. And don't worry at all about the poor quality. I think we gained a lot. And I hope you all agree with me. So we look forward to your continuing participation. And I'm going to end the stream now. So good day to you all, wherever you be. Just to remind you that in whatever it is, 6 hours time, Roger is holding a YouTube, sorry, I beg your pardon, a Zoom meeting, and anybody who wishes to participate may do so. So good day to you all.